We're going to look now at functions of more than one variable. This may be new to most of you. You have before one variable, f of x. That's not typical in a business, for example. There are usually multiple products. And so we have multiple input values, and that's why sometimes this is called multivariable functions, or functions of several variables. Suppose we have a company, and the sales per week depends on the advertising. So let's say that our function S for sales is equal to S of xy, where x is the dollars per week of newspaper ads, and y is the dollars per week spent on television ads. Okay. So this is the amount of money that's spent on the advertising, and S for sales is the resulting sales for that week in dollars. And the function is 10 times x to the 0.2 power times y to the 0.8 power. Suppose that we spend, or the company spends, $2,000 on newspaper ads and $3,000 on television ads. Then to find the resulting sales, we would put S of 2,000, because the x is the first coordinate, 3,000 for the second piece, and we substitute. 10 times x is 2,000, raised to the 0.2 power, y is 3,000, raised to the 0.8 power. So put these numbers in, I get approximately 10 times 4.573, that's 2,000 to the 0.2, times 604.919. You should be sure to check those to be sure that you get the same numbers. And that turns out to be approximately 27,662 $95. Now, I worked in 3 decimal places because I wanted my answer in dollars and cents. Since it's 2 decimal places, I needed to allow for rounding. So always work in more decimal places than you expect the final answer. And this is an estimate. If the company spends $2,000 on newspapers ads and $3,000 on TV ads, this is the amount of sales per week. All of these are per week values. Suppose they flip that and they decide to see what happens if $3,000 is spent on newspaper ads and $2,000 spent on television. So we're spending less on TV this time and more on newspapers. Well, that value turns out to be $21,688, rounded to dollars. So it looks like for a $5,000 budget, both are $5,000 total, it makes much more sense to spend more on television ads than on newspaper ads. This is just in general what your function of several variables could look like. Here we have a function of 2 variables set up in the form of a table. The values across the first row are the x values, and the values down the first column are the y values. That is the way it will always be set up in the lessons, and that is the way you need to set it up when we try to start doing this in Excel, which will make life very nice. As you read the table, we're looking at this now, the x's are the inputs, and let's say that we're interested in this value right here. So the x that goes along with that function value is 2,000. The y that goes along with that function value is 1,000. So this is the value of the function for f of 2,000 for x, and 1,000 for y. We still assume that our functions are functions f of x, y. If you have different letters, you'll be told which order they're to be written in. And the first variable is in the first row. Suppose we look at this value. This is the function value f of x is 1,000, y is 3,000. So this is the value of the function. You may recognize this number from a previous example when we had newspaper and television ads. This value was S of 2,000 for X dollars spent on the newspaper, 3,000 Y dollars spent on television advertising, and this was the resulting sales for the week. So this table should look similar, and you can find that in the lessons. Let's see if we can figure out how to actually create this table from the function that we saw before. What we want to do now is to create a table from a formula. This is the formula we've used before for the newspaper ads and television ads that create sales for a company. So I want to be able to fill in all the table by using that formula. Now, if you were going to do this just in Excel, you would write the equal sign first for the formula. Let's look in this cell right here. And then you would put 10 times, and you always put the times sign when you're multiplying between any two things in Excel. In the past, you would have selected your number, the cell reference, and plugged it in. This, if this is column A, B, C, D, this is row 1, 2, 3, 4. Then you would reference B, 2. I'm sorry, I've got my rows wrong. I have numbers here. That's row 1. 2, 3, 4, 5. This is in B1. And I would just write B1. The problem is, if I just put B1 and raise it to my power 0.2, as I drag down, my cell reference will change. Remember, B1 would suddenly change to B2, B3, B4, B5, but I don't want that to happen. I want to keep row 1 because that's where my X values are, in row 1. To maintain a constant cell, you have to put a $ before whatever you don't want changed. So if I want to keep row 1 constant, when I put in the B, I have to put $ and then the 1. That will keep row 1 constant. So as I drag down, I can stay in column B, and my row 1 entry here maintains this value for X to the 0.2 power. And then I want to multiply by Y. Y is in column A, but we don't want column A to change. We don't want to drag over to pick up different X's and have the Y values moving. So column A has to stay constant, so I put the $ before the A. And then this is in A2, so I have the $ A2, and that is raised to the 0.8 power. So this $1 for the X's, or whichever position in the sheet you're in, and then $ in front of the A for the Y's. You hit enter, and then you would drag it. You would have a value selected, and then you would drag down. So you would fill in your first column of values. You keep that highlighted, select the bottom cell, and then you drag across, and it highlights the whole table and changes all the X values and the Y values to fill in the entire table. Try that for yourself. It's done in great detail in the lesson, so you want to do it as you see it to be sure your numbers match. And this will give you the values that you need for your function. Always remember, times sign between any two things you're multiplying. Don't forget the $. If you have e to the x, remember that formula in Excel would equal EXP of whatever the cell is. Say if I'm starting here, if I want the E to the X, our X is in $1, and that would be the way to write E to the X. If you have a leading negative, if my functions say were negative x squared plus 2xy, then I would type equals -1 times. Remember, a leading negative in Excel you need to write like that. Cell B1, B, $1 squared plus 2 times X is in B, $1 times Y, $A2. So this would give me that formula in Excel. Formulas always start with an equal sign. Keep your -1. This is exponents. The lessons do a lot of the examples and show you how to put these things in case you have forgotten. So watch out for those. We've looked at functions of several variables in function form. We've looked at them in a table. At some point you might need to look at them in graphs, and it's a good idea to try to just orient yourself to where the values in the table appear on a graph. So typically X is our horizontal axis, but now we have 2 horizontal axes because the function values are still the vertical axes. So the F values that go up this axis, this is our vertical axis, are still the output values. This is still output. X values will be written typically along this axis, this horizontal axis, but think that they might also, you may see the numbers appear back here. You might see X-axis values appear at the top of a box, but the X values will always be parallel to what this axis is. The Y value axes are also horizontal, but they go back more, if you think about it that way. And so the Y values could be written along this axis. They probably won't be back here, although they could. And they could even be up at the top here or back here. If you have a point that has a certain X value, then you follow that out until you get to wherever the Y value is. And then you'd follow up to the vertical value, which would be somewhere on this axis over here. So you would have a point in the middle that references values on 3 different axes. And all the points in here combine to create a surface in 3D. It's a graph, but in 3 dimensions we call it a surface. And that's how we will create it from a data table and graph a surface. You've learned how to set up a data table for a function. Remember, the X values go across the top, the Y values go down. The values that appear after you type in your formula are the function values. So be very careful that you type correctly. Remember, if this is row 1, you want to be sure that the X values have the B. Okay. B, yes, $1, because we want to keep row 1 constant. That's where all the X's are. The Y values are in the first column, so we want to keep column A constant, so the $sign goes before the A, and this would start in row 2. So this would represent all the Y values. Be very careful when you type your formulas in. So we've typed them in, drug down the first column, highlighted it, drug across, filled in the data table, and I'm just putting up a portion of a data table here. It's the same as the lesson discussion problem. Now we have to graph it. So to graph, the first thing you do is highlight, and you highlight every number. So you start from your blank cell and you highlight the entire table, including all the X and Y values. After that's highlighted, The second thing you do is you click on Charts. That's the tab, the Charts tab. And then you search for surface, because the graph, if it's in 3 dimensions, which is what this is supposed to look like, it's in 3 dimensions, it's called surface, and it will be 3D. You may have to go down in the list of functions that are the types of graphs in order to find the surface. Once you have surface, you'll have a graph pop up. Well, the problem is, if you have a small data table, Excel may choose the column to be the X values and the row to be the Y values, and they won't match what you're supposed to have. So the third thing you do, you go back to the very top menu. Now, this is the Excel menu bar at the top of your screen, and you click on Charts, and then you look at Source Data, because you want your data, the X's, to come from the correct place and the Y's to come from the correct place. So the source data that you want to have, you have to find in the box that comes up only the one that says Category X Axis. And you check to be sure that the values that are assumed to be the X-axis are in your cells along row 1 from, if it's in the beginning of your worksheet, B1 right here across to where your data ends. That's the X-axis that you're assuming, and that's what you want to show up under this category X-axis. If that's true, you just click OK. If they're not those values over here are assumed to be the X values, then what you do is you click a button called Switch Row Column, and you just click that. It fixes that your graph will look different for the most part, and then you say OK, and you go back. So there are 3 things to be sure that you do correctly in order to get your graph to come up right. So we did that, and we have a graph that vaguely resembles this. Again, look in the lesson. It looks really nice and colorful there. And when you get a graph, a surface, you'll also have a legend. So all this is done. Now we go look at what the legend says. The legend will have a variety of colors in little boxes over here, or something over there. So this says that if it's colored black, between -1000 and 0 is where the data will lie. This starts at -700, and it certainly does go up to 0 on part of the graph. So there will be a band over here that looks like that. So this may be 0 up here. If this is the 0 on the vertical axis, this is the vertical, the function axis, I'll call it P. That's your function axis. This axis should be the X values. This axis should be the Y values. And as we saw before, those numbers could be on the back or on the top, but this is the general position. X is horizontal, and that's generally what we look at. All the numbers for the functions in here that are between -1000 and 0 will have this color. The next band may be from 0 to 1000, so there will be a different color. Maybe this is the blue band. And those will be all the numbers that are between 0 and 1000 will lie in that color band. And then there will be another color band for values, say, between 1000 and 2000, and that will be here. And this color goes all the way around. Wherever it shows up, that's the color band that says all the values for your X's at this point as you go in and meet Y values from this side. Every XY that lies in that part of the graph, that function value that matches that X and Y will be that color. So there are really 3 different ways you can compare this. You can look at a legend to check the color to see if it matches the legend. You can come over here and check the numbers. This says this goes from 1000 to 2000, and I do have values between 1 and 2000 here. If I had the entire data table that actually fits more of this graph, you would see a lot more color bands because there are a lot of values in there. And these are what you have to look for. Now we're going to look at some more information that you can get from your data and a three-dimensional graph, and those are called level curves or contours. Now, if you've created your three-dimensional graph, and we've looked at the legend here and found that the lowest colors, the lowest numbers for the function values are dark down here, and then we get up to higher numbers, we get different colors. Sometimes you'll find this in a grayscale. It won't be colored. It'll just be dark, very black at the lowest numbers, like in a pit. And as you get to higher numbers, the colors lighten up to maybe a light gray or a white. So we figure dark would be the low colors or low function values up to the light or white even for high function values. Sometimes they're colors. Excel does a good job of colors. These bands that we have here that come from our legend, try to visualize kind of slicing through your three-dimensional graph at this point. Every time there's a curve, along that curve is one function value. This band between the blue and the red curve here would be 1,000. Every function value along this curve between the blue and the red has a function value of 1,000. The x and the y's put into the function give you a value of 1,000. And if you drop those curves to the floor, to the bottom of where the xy plane is, you'd have just two-dimensional curves. Here they're sort of elliptical. This is sort of what it would look like. And again, this comes from one of the discussion not an example, the discussion example in the lesson. So you can actually see a better picture of both of these. So I've sliced through there, my three-dimensional figure, I've dropped them to the floor, and what I have is this, and this is similar to a topographical map. If you want to know heights, you can look on a topographical map and you can see color bands. Weather, you go look at weather and there are bands that show you wind speeds or temperatures. What these do is show us function values from our application that we were doing. Now, our three-dimensional graph, these are slanted X and Y lines and a vertical axis P. Over here, I don't have but two dimensions. I have a horizontal, which is X. So this direction of horizontal matches this direction of your 3D graph. The Y values, we go back and think two dimensions, these would be the Y values. That's X, and that's Y values. Inside here, these bands match the legend. The numbers within here give you your function values. So if I have X equal to 10 and Y equal to 10, I have a number in the middle here, which would be very high. And it would be here where X is 10 and Y is 10 would be up here somewhere. Maybe in this top band, a high number. Okay. The way the contour map matches here, my low function values are here at the edges, near where X is 0 and Y is 0, and also where X is 20 and Y is 0. So you can see if X is 20 and Y is 0, right in here is dark and low on the graph. As you check the 3D graph, and it goes down a little bit here, and you can't see it, but it goes down the back also. So these would be the darkest because they are the lowest function values, and they look like the bottom parts of the graph. The next numbers that go up, the blue is the next highest, between 0 and 1,000. This color band in here would be blue. That's where the legend says is from 0 to 1,000, and that's where you'd see this, the next height of numbers on the graph. And then the next band would give you red, which would match the legend numbers from 1,000 to 2,000. And then it would be lighter in the middle, a different color, but I don't have another marker, so I can't color that. That's white, and that would be the highest. Our legend just doesn't include it. So how do you create a graph that looks like this? Well, you've already got your data. you can create your surface graph. But then you can also just, in the same band where you created the surface graph in the chart and then surface, you have a picture that looks like this, and that's what you select. You can select one that looks in color or one that looks grayscale, that's just a dark black up to a lighter gray. You select it and you end up with a contour map that's just like this. The contour map, remember, has to match the legend, and the X and Y values and the legend numbers also have to match your 3D graph. So do be sure to check the examples in the lesson to see how this is done. It's in the same selection as the surface.